Hello. Welcome back, and we will be today continuing talking about the next steps of modeling the requirements. Next step of modeling requirements that we will discuss is modeling interactions and behavior. But just to remember what we did last time, so we were talking mainly about static modeling of the requirements. And in this step, mainly, we were focusing on class diagrams. So today, basically, we will be covering concepts mainly more related, let me say, to the sequence diagram, which is another type of diagrams that we will cover today, which is dynamic, not like the class diagram, which is static, okay? Static is usually when we describe something that are the classes, that are the connections, I would say, or association between the different classes. That is the multiplicity, that are things that will never change, that are the functions and so on. So this is static. It's not going to change. And there is no concept of time or order in that. However, when we will be talking today about the dynamic like modeling, or let's say the sequence diagram in particular, just an example. So here we talk about the word dynamic, where it means there is a concept of order, of time, of different steps that are coming in probably sequence. So this is the first one, then we have another one, then the third one. So here the concept of time is there. So at time t, we have this step, t+1, then we move to a next step and so on. So this is mainly how we talk about the modelization or the design, I would say, of the behavior and different the interaction or different like interactions describing the behavior of your system, and probably the different interactions if you ask yourself with whom. So here we have a very important like element, which is the user, because is like your user is going to interact after all with your system. So there is this exchange of like messages, or we will discuss all this today, okay? So this is mainly just a brief like overview so you understand what we will cover today. In like interaction diagrams in general are used to model this type or the dynamic aspect of software system, and they have to visualize like, for example, how the system runs, or like they have to visualize the interactions that could be built from the use case or and the class diagram. So in the first step, mainly we have a description, and here we are trying to understand what to do. First, we try to do during the analysis phase our use case diagram representing the main like I would say functionalities of your system, what your system does, who are the users or your different actors involved. Then we try to detail this in terms of like static modeling, still like in terms of class diagram. Now from both these we can move on to talk about the sequence diagram, okay? So the goal is to show how the different objects, because when we talk about the classes, the class diagram, we are representing objects after all. So here we kind of representing how these different objects are actually connected to each other in order to reach specific objective, okay? So most of these interactions in general could be between the user and the system, like we will see in the sequence diagram. This is what we will see today. So there are mainly, I will just explain this later, different types of sequence diagram, okay? But let's focus when we only have the user and the system is kind of a black box. We don't focus on different components of our object. So, okay, so we will keep that abstraction level in the start to kind of represent the interaction between the user and the whole system, I would say, as a whole, okay? In fact, so most of the objects are created in the sequence diagram, which means within the system, probably we have different objects. These actually correspond or represent the different classes that exist in your class diagram, okay? So this is how I'm doing the mapping between things to make sure that Like in the exam, for example, you have a use case like the description, and then what you need to do, you first need to make your use case diagram, then you will go for your class diagram. Once you're reaching to your sequence diagram, it's kind of connected to the previous steps. The elements of your system, they are the classes in your class diagram. So any mistake in this step probably can impact the next steps. So this is why I want to make it clear to make you guys aware, like you need to be very careful in the previous steps in order to ensure kind of consistency. It doesn't make any sense if I find in your sequence diagram some objects, when I check your class diagram, I don't even find the class representing that object, okay? So make sure that you have the main classes from your class diagram, and I will teach you this, so don't worry, we will see this and we will cover this with an example in the upcoming slides, okay? So when now we are going to show mainly the interaction between all the objects within the system and the interaction for sure with the external actor, I would say, which is your user probably. So this is what we are going to explore today in order to accomplish a particular or a specific task using the system, okay? So this interaction diagram so shows either you will find a set of actors, or I would say objects also, and they could communicate to each other. So keep in mind, it's not always that you have one user or one actor. You can have many. And the system that is a black box, we'll see this example in the analysis requirement analysis phase, it could be a black box, just to mention system and that's it. But once you go in the design level with more details, you need to specify the objects within your system. We will see these both two cases, okay? So the objects could communicate for sure, like to each other. So they could represent the implementation level in this case. So, and if I talk about communication, it means like the different calls between the object. And when I say calls, I'm talking about functions. Because if you remember in the class diagram, so what we've seen so far, so a class is a representation of a given object, okay? So for example, what do I have here? Like, uh, I would say I would take like this notebook. Okay, so I have this notebook. This notebook is something that I can touch, I can see, I can use for some specific tasks. So I usually you write my long to-do lists in here. So this is a real object. So can see it in the real world. I can use it. Imagine that I am creating a software where at some point there is a notebook. Let's say it's in the system, okay? We talk for sure about the, not the hard copy, okay? So this object could be represented with a class. So this class, it will take the name, like for example, class called notebook, okay? So this is a class. We've seen classes so far. So this is the class notebook. Okay, I always say that I write in worst way, but when I check the practices, you guys have the same skills. So I even don't understand my writing. So it's very normal. Sometimes I don't understand your writing as well. In this case, so I will show you something when I will be going through the correction of the practices. There is a very useful tool I usually used in my classes before. It's called Star UML. I mentioned this in the videos, and I didn't see until now because I'm still not going through all the like practices yet. But what I see is that mainly you all guys are just working like without using the tools. There is the online tool also, that Visual Paradigm Online. I will give you the link for that one, and when I will be working on the practice corrections, I can use one of that tools, so you can use that for your final project, okay? So here we have notebook, it's a class, and we said last time, we have for this class attributes, like for example, I don't know, for a notebook, what kind of attribute I can have. Maybe I have the width and height. Okay, just attributes are kind of characteristic of that object, okay? width and height. Oops, height. Oh, and so we have sometimes what we call the visibility. Mainly they are public. Okay, plus we mention here. It's okay, and this is used for something. For example, to write. So there is a function, write task or whatever. I'm just giving an example. Okay, why I'm giving this example? Just to make things clear, write like task or to do or whatever, which is a function that we can like or get width and get length easily. We cannot set for sure. We cannot modify means. So this notebook now it's not a real object anymore. So we have the class notebook, and so this class now, if we want to represent in a like sequence diagram, we have our user, okay, who's going to system to use the system, and in the system somewhere there is a notebook object that could be like the user can access to one of the functionalities, I mean, of that object. Okay, so I will teach you more about the representation, but mainly this object have the method like write to-do list. So we are going to execute this method. So here we have this arrow, and please make sure it's open here, like we don't like color this, or it's very important the way to write things because they are norms, they are rules that everyone is using. So it doesn't make any sense if someone is doing arrow like this. Arrow like this, it means something else. It means we've seen that this is for kind of generalization. It's not used for this. You cannot use this arrow. Also, it's good that you color from here. So this has a different signification. So try to make sure that you use the right like arrow. So I will teach you more probably about this. We will see all the details, but now just leave it and focus that if user is having kind of an arrow towards an object, means that object executes that method, or it has the implementation of that what we say function, and that function, as you can see here in the class diagram, so it's somehow implemented. So when you have your class diagram, it's easy for you to translate that into like a sequence diagram. Okay, just don't now care too much about this like notations. I will go in details of how to represent the lifeline user and so on. Just here I wanted to show you the mapping or the relationship between class diagram and the sequence diagram, and to make sure that the function, for example, exists within one of your classes, it must show somewhere in your diagram. Okay, and this is mainly the idea. So the interaction probably it shows like that, like a row I'm just drawing now, that shows the kind of a communication like between here the user and the object. There could be communication between different objects that you have, which are translate your different classes in the class diagram, and this is what we call the sequence diagram, like messages. They are the exchanges between the different objects. Okay, so a sequence diagram now will contain instances of classes. Okay, we call them also objects, actors also we have, and actors that are in general those who are um, like we use the stickman or stick person symbol just to illustrate them, the same like in sequence diagram. Okay, like this. I said that we need to make it perfect. Okay, and after that, so what we have the different messages, and these are shown with the arrow from the actor to the objects. Okay, or from the object to the other object. This is what I was just discussing now. Okay, so when we like kind of develop, or you develop mainly your sequence diagram, try to make sure that you make them consistent, and I'm saying this again and again, make sure you make them consistent, please, with your use case and with your class diagram. Okay, and you cannot actually start modeling the behavior before even having your use case diagram and class diagram. So the order is very important. It's not like in the projects of you will jump and you will do sequence diagram. It cannot happen. In the exam, you will skip the first two questions and go for the sequence diagram. It cannot happen. So you must focus with the first steps before, and then like you will be ready to move on to your sequence diagram. So there are two kinds of interactions diagrams. There are the sequence diagrams that we will cover today, and there is another kind of closed type of diagrams, which is the communication diagram. Okay, mainly we will not focus much on communication diagram. Today we'll mainly focus on sequence diagram. Okay, this is how a sequence diagram looks like. Okay, and when I like say the user, so we present it as stickman here, and here we have the user is our passenger. Okay, and the system here, so we have only one element, so mainly this is the system that the user is going to interact with. Okay, so this system kindly it's kind of, now it's only one object. It's a system, it's a ticket machine. It's a kind of a black box. I don't know, there could be in the ticket machine other objects, but now I'm just making it one object. So this is like what we discussed in the requirement analysis. We can define the different like scenarios of the most important use case. Okay, so we are defining this without diving into any details. Okay, the sequence diagram could be used in order to visualize these scenarios, like for example here the interaction between the passenger and your ticket machine. Okay, and also like again it can even show interaction between objects themselves. Probably I will jump quickly here. You see you have many elements. This is not the system black box. There are different elements of your system, well like designed. They are correspond to some classes. I will come to this. But when you see only one element, this is when you are talking about the sequence. This is in the analysis phase. Next, if you are making it more detailed, more like elements, more I mean objects, so this is the design phase. Okay, so let's only focus on this for now. So during the requirement analysis, we kind of like refine the use case description. We kind of find additional objectives, like use like this during the system design. Next, to refine the different subsystem interface. Okay, could be also used during the testing phase to specify expected behavior and validate the output. Okay, and now if we have some classes or your system, this is going to be represented by rectangle. It's very important. And if you have like some here for each object here you have a type a lifeline. Okay, or it's also called timeline. Okay, I will just show you right here. Like when you have your here user, okay, and so this user mainly is something that is going to exist but not forever. Okay, so at that time it is existing, we represent that with kind of dashed line. Okay, vertical one. Also whatever the object that you have here in your system, it's also it has its own like dashed line. So this dashed line, like it's mainly like shows that this is existing, it's there. Okay, so this element is having this, let's say lifeline or timeline, or it's like I would say the object like could be destroyed, because at some point probably this class I will not use anymore. Okay, so it's this dash line, it's finishing, it means it's like it's destroyed. Okay, so the lifeline, if it's finished, that so kind of we will not use this instance, I would say, or object anymore. Okay, then like also I say you have your messages, they are represented so now with by arrows. Now if you have a given message, now for example I will discuss later the difference between that arrows that are here we fill or we color with the black color, and the types of arrows that we don't like fill and so on. So now it's not our topic, but I will keep it simple, sorry. And just I will not go in more details. So let's come back. Once now, like this user started sending messages, means within his life, like timeline, we represent some activations. Okay, so these are the vertical, I would say, rectangles, like little or narrow rectangles here. They represent that this is like in the activity, it's active. Okay, so when sending the message, like for example, the passenger is sending the message, select zone to the ticket machine. So also here, this ticket machine is start being active. Let's say it's activated. So here also these like narrow rectangles, they represent the activation. Okay, for a given, like I would say, period or slot of time. And so if here, for example, at some point it's finishing, so we close it, and that's it. Okay, so for each element we have some activation and so on. Okay, so this is just an overview. Now we go to like a concrete example, let's say. So what you see in the bottom, or on the bottom here, sorry, so it is a hair. This is a class diagram. Okay, so it's just an example, okay, of a class diagram from which we can generate one possible sequence diagram, because we said that if we have a class diagram, we can move on to the next step for a sequence diagram. So from here, what we will do, no, see, you have here like different objects, okay, of the sequence diagram. Okay, so from where you're having these like objects in your sequence diagram, so they mainly correspond to classes that actually exist in your class diagram. Like here, you have instance, course section is object. This you have somehow your course section class. Here you have the class registration, you have instance registration, class student, instance for student, and so on. Okay, for each of them we draw that like Lifeline. And if you are using the online tool, like for example the Visual Paradigm Online, or you download locally star UML, so that is going automatically. If you insert, like I will show you later, you insert like object, it comes up with its like Lifeline. Okay, so here now what we have next different messages. So you see here the difference between the types of the messages. We have this one, it's like we have the full, like here, colored black arrow. So this represents the message user or whoever is sending, and this function request to register here is somewhere a function that is request to register. This function, it's existing, this arrow is entering where, to the course section, this like instance. So when you go to course section, you must find the direction of the arrow. By the way, it's very, very important. It means this method is implemented in this class, when it comes to the class diagram. Okay, next, what you have, so the user is going to request to register for a course section. Okay, now for create messages in general, so this is going to create a new instance, which is the registration. So create messages, to create new instance, usually they are like a dash, like line you have, and it's not like curved. This is just an open, like kind of arrow. So here is this instance is going to be created. This is why you see here it's active. It starts being active. Now, once the registration is done, now what we have? We have the add to registration list method is going to return that to the course section. So this method, the arrow is coming to course section. So this is why it's implemented in the course section class here. So add to registration list here, it's implemented in this class. Okay, so as long as you have these two arrows, direction is coming towards, like it's entering to this class, this like instance of the object. So it means that these are two methods implemented in this class. Okay, randomly I will select one class. This is like instance student. So I go and check the class student. Now, what method here you have entering here? Like you have add to schedule. Okay, so this add to schedule is coming from where? You go and check in the student like class. There must be implemented the add to schedule method. So you make sure that if the arrow direction is coming in, like entering like in this like instance, it means that this is mainly implemented in that class in when it comes to the class diagram. Okay, and now this message is coming first, the request registration. So this is why, like we talk about the idea of like dynamic modeling, which means that like we have this like concept of order. So the user first, this comes first, executes the method request to register, which is implemented like or the instance course section implements it. This is going to create a new instance of registration, and then it's going to send a message to the like instance of class student to add to schedule. So and then the registration at the same after that is going to execute add to registration list to the course section. So in this class diagram, what you see is that the messages are going mainly in one like kind of requesting something or executing a method. Sometimes if something is done, so there is an answer. The answer is like the create message. It is represented with a dashed line and like this arrow, and we can mention like if something is done. Okay, like for example registration done. Okay, or just simply we mention registration means it's done. Okay, for example registration done. Okay, just means like you asked for registration. This was the process that is happening in the background, like between your different instances of or element of the sequence diagram, and this is the like result or the output, like it's the registration is done. Okay, so this is mainly the idea. Now I will not like detail things more. I don't want to make my videos long, but at the same time I would love to explain everything for you guys. Okay, now let's just move on quickly. So the sequence diagram so mainly shows the different messages that are exchanged by the set of different objects that we have performing certain tasks. Okay, so in general these objects are arranged kind of horizontally. Okay, and we have them like represented, I would say, across the diagram. So you can also represent different actors. It's not only you have only one actor, you can have many, and that actors can initiate this interaction. This is also shown like mainly in general when you have on the left side of your sequence diagram the different like dimensions or vertical dimensions that represent in general the life of your different objects. Okay, and this is represented, we say, by dash line again. And so we have different messages as well that could be exchanged between these activations boxes, and the sender and the receiver also could be different objects in the sequence diagram. Okay, so just a summary of what I was explaining so far. Here, like mainly is a more detailed example, more complicated, let's say. Like you can, for example, go just beyond simple messages or like activation boxes to define like your in your class diagram. So mainly this is we are used to it. This is our users. These are the elements of your system, which are classes, instances of the classes coming from your class diagram. You have here different interaction. What is mainly interesting in this one is this opt, I would say, part. So there are different like things like this we call combined fragments. Okay, we will start with the first. We'll see four combined fragments: the opt, the ref, the loop, and the alt. So for the opt, it starts with opt. I always tell to my students, start with opt means optional, optional, okay? So it's kind of an optional part in your diagram, which means that you can like skip this part. It's not mandatory. And if there is here some condition, like in this case, like there is a user, it's going to request to register in the graphical user interface. Then the course section executes the method request to register given a student, that student. And so this will go to execute or to get the list of prerequisites. So we are going to have them, and then like we check if like it has or not prerequisites. So let's say if it's possible, like the course has prerequisites. So in this case, so it cannot have. So this is mainly an optional block. So if it has, then we have all this. There is a creation of the registration, like instance and different other messages. So this is just an optional part. Next, now the ref, it's mainly, we are going to call or ref or reference, I always say to them. So we are going to reference or like another like diagram, okay? So in this one, I remember, I'm sorry, I just had another slide for if it was at the end. Okay, no, it's the right one, sorry. Okay, so this was the slide for if. What we have for if, I will have my pen to give you the example of authentication. So ref is for reference, which means when we do use this reference part is when we have at some point a sequence diagram that is going to be used and reused and reused, and I would say recall. Many times we are going to use the same part. So we don't need to make our diagram very long by diagrams, I would say, because we can have for different use cases different sequence diagrams describing behind this what happens in dynamic like access. So for a given use case, we have the authentication could be required, like to add a friend. And then another scenario that we can describe is to let's say post or share something. So for this also we need the authentication, okay, or login. So login, if we will mention the steps itself, so it has a long process. So what we have, we can create the sequence diagram that is made for authentication. So we mention here sequence, okay, and that we give the title of our diagram because this is mainly corresponds to some use case. So here for the use case, usually it has the same authentication. I prefer if you guys will take some notes with me, so maybe your writing is much more nice. So here you have the sequence, means sequence diagram for authentication. Okay, the title is authentication. Now what you have is the user, okay, and this user is going to interact with, I would say, with kind of the ATM. I will take the example. Okay, I'll not complicate life with the social like media example. Let's just take the simple ATM, and we have the user. This is the line of both elements that I have, the user and the ATM. Now what we have, or the user is mainly the client, okay? So it's a client somehow. And so the idea is that how it works, the authentication when you go to ATM. So usually the ATM is going to request like code from the user. So we have request code here. What will happen? That the user next is going to, this is a message, okay? To send the message, he's going to insert code, okay? I don't know why it don't look like insert code. Okay, insert code. Next now, it's what will happen. There will be a self message here that we do like this. I was teaching this before. So this is the verification. Usually when the system like makes verification. So this is a self message, okay? So verification. Once it's verified, let's say that he will give access, okay? Let's say this is the answer. This is why I'm doing it with a hash line. So let's mention here access. So this sequence diagram, just making it simple with only 4 messages. Sometimes the authentication is a very long like scenario with some options, some conditions, and so on. So if I have, or I'm going to design another sequence diagram, for example, which is corresponding to the use case of the sequence diagram for, let's say, checking your balance or for balance consultation, I would say. Balance checking or consultation. You're going just to check on consult. Okay, so what you have in this? So you have the same actors. This is very important because you're going to use something from the other diagram. So you must have the same actors, by the way. So here you have your ATM and your client. And again, you have that -9 for the life. And by the way, here we have the activation. So this is active and this has been active during this time, let's say when it was doing the verification. Okay, so just I'm making it nice. It's not nice at all. So the client at ATM. Now we're going to see for checking the balance. For checking the balance, the first step is what? Is authentication. So this user is going to request code, then the ATM is going to request code, user is going to insert code, ATM is going to do run or some verification, then it's going to give access, which means this is going to repeat. It's the same like this diagram. So what we do in this case, we make like this little rectangle, okay? We don't give it that much space that we give it for details like elements, and we use the ref like combined fragment like this we mentioned ref, and here we only write the name of this like use case like authentication sequence diagram. So the name of the sequence diagram authentication here we're just doing ref and we are writing the same name, which means that these are the same steps that going to be, and it's kind of just a recall, okay? And next, now we have for this balance check what could be like the possible like like for example the user or the client is going to consult account, let's say, and as a result, like when he's consulting his account, he will see like his balance. Okay, it's going to be shown. Okay, so just simple. You can have another type, like for example, request credit card. Request credit card like sequence diagram. There is the request of the credit card and the approve or reject. So, but before that, you need to do the authentication. So you can just use this block, which is the ref authentication. So it's used to reference another sequence diagram. It allows the reuse of like a part of the sequence diagram in like another one. Okay, so this is mainly the idea of the combined like fragment ref. Okay, ref for reference, opt for optional. Now let's move on to the next one, which is the loop. Loop is like kind of repetitive exchanges of messages between actors in your system. You have notification. It could be loop, like here when I don't mention, I don't know how many times it's going to be repeated, okay? It's infinite loop, okay? Next, we can have a loop, something which is going to be repeated for an exact number of times. Like for example, here, uh, loop 10, it's going to execute this notify like function exactly 10 times. Or we can mention in the loop here, like we can mention the lower bound and the upper bound, which is the minimum and the maximum, I would say. So this loop should be executed minimum 5 times and maximum 10 times, okay? Here, Like probably is an example of loop. So here we have this is going to iterate over the objects like n times, okay? So this is just the example if you want to add like the iteration in your sequence diagram. So you create this loop and so you can have this continuous like I would say exchange of messages since here you are not mentioning the exact number or the min and max. So this is going to be repeated, so this continuous exchange between the bill purchase item and the other elements of the system. And so this is going to be happening until that like I reach a specific number of purchases, for example. Okay, so here we have the counter number of purchases. So it's possible that you actually specify this box like of the loop in your sequence diagram to make it more detailed. Okay, so here also we have the last part, I would say, of combined fragments, which is alt, and alt is for alternative. Okay, it's always this start with opt optional, alt alternative, ref reference, and we have the loop. So alt for alternative, which means we have different alternatives. Optional, it's one option only. When you have more, it's different alternatives. So it's kind of the if else statements. If like I have some condition, like for example, my balance is more than zero, it will accept to probably withdraw money. If I don't have, maybe it's a reject, let's say. So it's kind of modeling or design representing, I would say, the different possible scenarios. And you mentioned here your condition, okay? Don't forget that. You can have more than just two. You can have multiple. So you just separate them with a horizontal hashed line, okay? Now this I was explaining before that at a given point, some objects life end, and so just shows like with this X at the end of the lifeline. Okay, so here is also another example of sequence diagram where you have different objects. So you have these are your different objects and you have only one actor here, which is the customer, and you can use the exchange of the messages between these different actors and the object, like and the size, like for example of the activation box you can see in here. So it shows how long this like or that element was active. And so this example is probably one of the basic sequence diagrams. And as you may probably wonder, you can take any of the detailed scenarios that you created for your use cases and actually visualize them with or using these sequence diagrams in general. Okay, so mainly that's it. I try to explain sequence diagrams. But still, if you have any questions, never hesitate to just ask. Okay? Thank you so much. Thank you for your time.